Welcome to Rani Chemistry classes. In this video, I am going to discuss about what is bond order, how bond order is calculated, and some examples and shortcut method for the calculation of bond order. So bond order means, according to the molecular orbital theory, bond order is the difference between the number of bonding electrons and antibonding electrons divided by 2. This is given by bond order equal to number of bonding electrons minus antibonding electrons by 2. So according to molecular orbital theory, electronic configuration up to 14 electrons is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, pi 2px2, pi 2py2. These two are degenerate orbitals. Next, sigma 2pz2. According to molecular orbital theory, if the molecule contains more than 14 electrons, then the molecular configuration is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2pz2, pi 2px2 equivalent to pi 2py2, pi star 2px2 equal to pi star 2py2, sigma star 2pz2. For example, consider an example, that is carbon monoxide or N2 molecule. In carbon monoxide, carbon atomic number is 6, oxygen is 8, so total 14 electrons. Or another example, N2 also contains one nitrogen contains 7, another nitrogen 7, so total 14 electrons. For 14 electrons, the electronic configuration is, molecular configuration is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, pi 2px equivalent to pi 2py, 1, 2, 3, 4. Next, sigma 2pz2, sigma 2pz2. Here, number of bonding electrons are 10. That means without star mark, 2, 4, 5, 6, 7, 8, 9, 10. So bonding electrons are 10. Anti-bonding electrons means star mark, that is they are having higher energy, 2, 4. So total 4 electrons. Bond order equal to number of bonding electrons minus anti-bonding electrons by 2. So 10 minus 4 means 6 by 2. So bond order is 3. So that means in between the two nitrogen atoms triple bond is present. So in this according to this molecular configuration, all the electrons are paired electrons. It contains all the orbitals are containing paired electrons. So its nature is diamagnetic. Next, second example, O2. O2 means oxygen atomic number is 8, so 2 oxygen atoms, 8 plus 8, 16 electrons. So molecular configuration is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2pz2, pi 2px, pi 2py, 1, 2, 3, 4. Next, pi star 2px equivalent to pi star 2py. Here 2, 4, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16. So these two are half filled. That means they are containing, this pi star 2p orbital contains unpaired electrons. So it is paramagnetic. Here number of bonding electrons are 10. So this 2, 4, 6, 6 oka 4, 10. Antibonding electrons means 2, 4, okay, 2, 6. So total 6 antibonding electrons. So bond order equal to number of bonding electrons minus antibonding electrons by 2. So 10 minus 6 by 2, that is equal to 2. So this molecule contains unpaired electrons. That means unpaired electrons in pi antibonding 2p orbital. So it is paramagnetic. O2 molecule is paramagnetic. This table gives the bond order of the some of the examples. Hydrogen, so total electrons are 1 plus 1 equal to 2. So bonding electrons are 2, anti-bonding 0, so bond order 1. Oxygen already we have discussed, 8 plus 8, so total 16 electrons. Bonding electrons are 10, anti-bonding electrons are 6, bond order is 2. 2 means in between the two oxygen atoms double bond is present between the two oxygen atoms. Fluorine, so total atomic number is 9, 9 plus 9, 18. So bonding electrons are 10, anti-bonding electrons are 8, bond order is 1. C2 molecule, that is bonding electron carbon, 6 atomic number, 6 plus 6 means 12 total electrons. So 8 bonding electrons, 4 anti-bonding electrons, bond order is 2. Diborane B2, boron 5 plus 5, total 10 electrons. So bonding are 6, anti-bonding are 4, bond order is 1. Dilithium Li2, lithium atomic number 3, 3 plus 3, so total 6 electrons. 4 bonding electrons, anti-bonding electrons are 2, bond order is 1. Beryllium diberyllium 4, beryllium atomic number is 4, 4 plus 4, total 8 electrons. 4 bonding, 4 anti-bonding. Bonding electrons are equal to anti-bonding electrons. In this case, bond order is 0 and this molecule is also unstable. If the bond order is 0, this indicates that that molecule cannot exist, that is unstable. Next, cyanide, carbon 6 electrons, nitrogen 7 electrons, minus means add 1 electron, so total 14 electrons. So bonding 10, anti-bonding 4, so bond order is 3, that means in between the two nitrogen atoms, triple bond is present. Here bond order is always directly proportional to the bond energy. It is directly proportional to the bond dissociation energy and it is inversely proportional to the bond length. Okay, so more the bond order, lesser will be the bond length. So here shortcut method is there. We know in nitrogen total electrons are 14, bond order also 3. First to write 14 electrons total, bond order 3. So this side decrease the bond order by 0.5. So here electrons increase 1, 14 electrons, 15, 16, 17, 18, 19, 20. This side 13, 12, 11, 10, 9, 8 like this. Here bond order is decreased 0.5 this side and this side. So here 3, 2.5, 2, 1.5, 1, 0.5, 0. So in competitive examination, this table is very useful by asking the bond length and bond order for different examples. This table is very useful and you can calculate know the answer within fraction of seconds. Okay. So the sum of bond order of O2, O2 minus O2, O2 2 minus O2 2 plus is equal to, O2 means bond order, total electrons is 8 plus 8, 16 electrons. 16 electrons means bond order equal to 2. Here bond order is equal to 2. O2 minus, so 8 plus 8, 16 plus 1, 17 electrons means bond order equal to 1.5. O2 minus 2. O2 means 16 electrons, minus 2 means add 2 electrons, so total 18 electrons, so bond order equal to 1. O2 plus 2. O2 means 16 electrons plus 2 means subtract 2 electrons because it loses 2 electrons. So this is 14 electrons, so bond order is equal to 3. The sum of the bond order of O2, so 2 plus 1.5 plus 1 plus 3, this is equal to 3 plus 1, 4, 5, 6, 7.5. 5 wait. 2, 3, 4, 5, 6, 7.5. It's O2, O2 minus. O2 16, bond order equal to 2. O2 minus 2, 8, 16, 1, 17 electrons, 1.5. 16 plus 2, 18 electrons. 18 means bond order 1. 14 means bond order 3. 3, 4, 5, 6, 7.5. Here the question may be wrong. Here we are getting bond order is 7.5 is the total. So bond order is 7.5 is correct. Okay. Here maybe some charges may be lacking. Okay, for this question we are getting 7.5 is the bond order. Next, which of the following pairs of species have the same bond order? CO carbon 6, oxygen 8. 8 plus 6, 14 electrons. Nitrogen 7, oxygen 8. 15 electrons. They are different. O2 16 electrons. Nitrogen 7. O plus means 7. So total 14 electrons. Here Cn minus means 6 plus 8. 14 electrons. Carbon 6, oxygen 8. 14 electrons. So this is having the same number of electrons. That means bond order also same. Total electrons are same, bond order also same. It is not necessary to calculate the bond order because the total electrons are same, bond order also will be same. In this case, nitrogen maybe N2. N2 means 14 electrons. Oxygen 16 plus 1, 17 electrons. So option C is the correct one. What is the correct decreasing order of stability for O2, O2 minus, O2 plus, O2 minus 2? Stability means more will be the bond order, more will be the stability. Here O2 means total electrons are 16. So bond order is 2. So O2 minus means 17 electrons. So bond order is 1.5. O2 plus means 16 electrons. So 15 electrons. So bond order is 1.5. O2 minus 2 means O2 16 plus 2, 18 electrons. 18 electrons means in the table 18 electrons means bond order is 1. Okay. So the stability is more for the ion or molecule having more bond order. So O2 more bond order. 15 electrons means 2.5 bond order. Here 15 electrons means 2.5 bond order. Okay, so O2 plus more bond order. Next 2 O2, next 1.5 O2 minus, next to O2 minus 2. So this option is present in O2 plus, O2 minus, O2 minus 2. So option A is the correct one. Okay, here bond orders are also given. Which of the following species has the smallest bond length? Smallest bond length means more bond order. Molecule having more bond order have more bond order means bond length is less. Bond length is less. Here for NO molecule, for nitrogen 7, oxygen 8. So total 15 electrons. Nitrogen 7, oxygen O plus means 7. 14 electrons means bond order is 3. O2 plus 16 electrons, bond order is equal to 2. NO minus, nitrogen 7, O minus means 9. 9 plus 7 means 16 electrons. 16 electrons means bond order 2. Next 15 electrons means bond order 1.5. Here we know 14 electrons, bond order is 3. 15 2.5. So bond order for 15 is 2.5. Bond order 15 is 2.5 bond order. So here more bond order is present in NO plus. So it is having the smallest bond length. So option B is the correct one.